Hello students, this is your review for Math 0306 Exam 2. Exam 2 will cover Chapter 5, Systems of Equations, Sections 1, 2, and 3, and Chapter 6, Exponents and Polynomial Operations, Sections 6, 1, 2, and 4. Remember that much of this is review. In Chapter 5, Systems of two equations in two variables is considered review material from the previous level of math. 5.2, Systems of three equations in three variables is considered new material, and also the applications section 5.3 is considered new material. In Chapter 6, all of Chapter 6 is considered review material. So the rules of exponents should be a review. Adding and subtracting and multiplying polynomials should all be review materials. We're going to start with a couple of examples from 5.1 where we review how to solve a system of two equations in two variables. I'll do one example of solving by elimination and one example of solving by substitution. So the first example we'll look at is this one here, solve the system. And you notice we have two equations in two variables. Okay, both equations have the variable x and y. Now this one is set up nicely for solving by elimination. So I'm going to demonstrate solving this system by elimination. So in elimination, we want to add the two equations together to eliminate a variable. So we don't have any opposites to start with. So we have to multiply one equation or both by something to create opposites. So I would just look at 4x and 2x here and say I could easily multiply by negative 2 to create a negative 4x. That would cause this x term to eliminate. So I'm going to put a parenthesis around the entire equation and show that I'm going to multiply by negative 2. I'm going to rewrite that to the side here with the multiplication done. That becomes negative 2 times 2x is negative 4x. Negative 2 times 4y is negative 8y. Negative 2 times negative 18 is positive 36. And now I'm going to bring equation 1 over, rewritten with no change because I will have a chance to eliminate the x's here. So it comes over with no change as 4x minus 3y is equal to 52. Now I'm adding these two together to eliminate x. Right. And that happens this way. 4x and negative 4x adds for 0. The x's are eliminated. I add my y terms for negative 11y and I add my constants for 88. Now I need to divide both sides by negative 11, and that gives me y is equal to negative 8. Now at this point I have solved for one of the two variables in my two equations. At this point I can substitute the value for y, negative 8, into equation 1 or 2. Once I substitute a value for y, I'll be able to solve for a value for x. So I'm going to pick equation 1. It doesn't matter. Remember, you should get the same value whether you choose to substitute into equation 1 or equation 2. So you can choose. I choose equation 1. So equation 1, 4x minus 3y is equal to 52. And I substitute the value negative 8 for y. So 4x minus 3 times negative 8 is equal to 52. Now I'll carry out the multiplication here. 4x, negative 3 times negative 8 is positive 24, equal 52. And now let's see, we'll subtract 24 from both sides. I'll show it this way. And that gives me 4x is equal to 52 minus 24 is 28. I now divide both sides by 4. And I get x is equal to 7. Now I have a potential ordered pair here, 7, negative 8. Remember, if I'm solving, whoops, I left you hanging there. I'm solving a system of two equations in two variables. Then I'm going to get a value for two variables. My solution should be an ordered pair. Okay, so I'm going to say that my solution, I believe, is the ordered pair x value 7, y value -8. Now, to make sure that that's correct, I'm going to check these values in both solutions. So equation 1, I'm checking. For x, that would be a value 7, minus 3y, that would be a value -8, equal 52. Let's see if that checks. That's 28 plus 24. Does that really equal 52? And you can run that in your calculator and find that it is true. Let's also check those values in equation 2. 2x plus 4y. So 2, replace x with 7, plus 4, replace y with -8. Does that really equal -18? Okay, so let's run the math on this, see if it checks. 2 times 7 is 14. 4 times -8 is -32. And let's run that and see if it really works. 14 minus 32, run that into your calculator, and you do get -18. Right, so that we can we have proven that this ordered pair works in both equations to produce a true statement, so we know that this ordered pair is a solution of the system. It's a solution of both equations, so it's a solution of the system. Okay, let's look at another one. This system, two equations here in two variables, and we demonstrated the process of solving by elimination, and so now I will demonstrate solving by substitution, just so you can have a reminder of how that works. This one is a good candidate for substitution because we can easily isolate the y here. So I'm going to rewrite equation 2 with y isolated. So what would that take? I would need to add 6x to both sides. So rewriting equation 2 would become y is equal to positive 6x with my positive 44. Y is equal to 6x plus 44. And I'm going to write equation 1 with no change. 7x plus 5y is equal to -2. And now to demonstrate substitution, I'll say if y is isolated, then I can take the other side of equation 2. Let's let that clear up here. We'll take the other side of, alright, so we'll take this side of the equation, which is equal to y, and substitute it in for the y in equation 1. So I'll rewrite equation 1 now with the substitution done. Equation 1, 7x plus 5y is equal to -2. And when I rewrite it, 7x plus 5, I'm going to stop at y and replace y with the parentheses 6x plus 44, and I will continue the equation equal -2. I'm going to carry out the solving for x here, so I need to distribute 5 to the parentheses. 7x plus 30x, 5 times 44, that would be 220, is equal to -2. And now I can collect like terms here. 7x and 30x is 37x plus 220 is equal to -2. And then I'd like to begin to isolate x. So I would subtract 220 from both sides. I'll show it that way. Gives me 37x is equal to negative 222. Now I need to divide both sides by 37. That gives me x is equal to, calculator on this gives you negative 6. Now I have solved for the x value in the system. Okay. Alright, now my job is to solve for the y value. And I pick equation 2 in this version here because y is already isolated. That would be the easiest. So somewhere I need to show that I'm going to solve for y. So I'm going to take equation 2 in the form y is equal to 6x plus 44. I'm going to rewrite equation 2, replacing x with negative 6 plus 44. I'm going to perform the operations here. That gives us negative 36 plus 44. And when I add those numbers, I get y is equal to 8. So again, that gives me a solution for x and a solution for y. So the solution to the system should be the ordered pair, negative 6 x value, 8 y value. And remember, I need to check those. Okay? That solution needs to work in both of the original equations. So we're going to check number 1. That's 7x plus 5y is equal to negative 2. I'm going to use the value negative 6 for x and the value 8 for y. And we're going to see how that works out. 7 times negative 6 is negative 42 plus 5 times 8, that's 40. And negative 42 plus 40, you can run that in your calculator and see it does actually equal negative 2. And let's check for equation 2 as well. I have negative 6x plus y is equal to 44. We're going to replace x with negative 6 and y with 8 and see if that actually does equal 44. So run the check here. That gives us negative 36 plus 8. Oh, I missed something here. Let's go catch it right quick. It's not looking right, and let's check our math. Negative 6 times negative 6. I did plug in correctly. I substituted correctly. I multiplied incorrectly. So let's catch that. Negative times negative is positive 36. That works out much better for our check here. That actually does add for 44. So that means that our solution, negative 6, 8, is correct.